All right. So this first bit of this lecture is about classification of alcohols. There are altogether three types of alcohols: primary, secondary, and tertiary. All right. So how to classify these, how to identify which one of the alcohols is a primary, which one is secondary, and which is tertiary. If you look at these diagrams on your screen, the first one over here is C3H87 and OH. You look at the carbon, which is underlined here. This carbon is attached to two hydrogens, one other carbon, and one OH. And it's stated this one is a primary alcohol. So you see any alcohol which is attached to one carbon chain and one OH. OH is the hydroxyl group, which is, the functional group of alcohols. Okay. So any carbon under discussion, if it's attached to one carbon chain, on one side it's attached to a carbon chain, on the other side it's attached to a hydroxyl group, it's always a primary alcohol. All right. Similarly, a secondary alcohol is attached to two carbon chains. So there will be carbon chains on two sides of a secondary alcohol, and one of the sides would just have this hydroxyl group, and the leftover side would have a hydrogen. This is the identification of a secondary alcohol. It will have two other carbon atoms or two other carbon chains alongside it. Similarly, a tertiary alcohol will have three other carbon chains. For instance, if you look at this central carbon here, this one under discussion, now this carbon has three carbons attached to it, and the leftover side has a hydroxyl group. So any carbon occupying the three sides being occupied with these carbon chains is known as a tertiary alcohol. Okay.
Yes.
So yeah, so this is how you identify or differentiate between a primary, secondary, and tertiary alcohol. You see, now all of these alcohols could be there in a single compound as well. If you look at this last molecule, you see there are three carbons altogether. And if you look at the first carbon is attached with one other carbon, one hydroxyl group. So this is a primary alcohol. Now, if you just talk about the second carbon is attached to three other carbons and one hydroxyl group. So this is a tertiary alcohol. And the last one, because you see, there could be more than one alcohols in a single compound depending upon the functional groups. So in total, this particular compound has three hydroxyl groups. So there are altogether three alcohols in just one compound, because you count the number of molecules by looking at the number of functional groups present. Okay, this is the reason why there are three alcohols, and all of the three alcohols are different. One's primary, one's secondary, and the other's tertiary. Okay. All clear up till now?
Yes.
Okay, great. So, oxidation of alcohols. Only primary and secondary alcohols are oxidized. Tertiary alcohols cannot be oxidized. That is a fact. And in order to check for oxidation, you can use an oxidizing agent. For instance, potassium dichromate, which is K2Cr2O7. And if, let's say, you add potassium dichromate to a primary alcohol, you're going to get aldehydes. Have you studied aldehydes before?
No.
No, okay, we're gonna get to aldehydes as well, but later. All right, let's just keep it on hold for a while. So aldehydes are this is another functional group. It's another family of organic compounds. You get aldehydes if you oxidize a primary alcohol, and you get ketones if you oxidize a secondary alcohol. Ketones are also another organic compound family. We're going to talk about that as well later. So primary alcohols will always give you aldehydes upon oxidation, and secondary alcohols will always give you ketones upon oxidation. We're going to look at the mechanisms as well later. We'll see why is that exactly happening. All right. And tertiary alcohols, they cannot be oxidized. Their oxidation is not possible. Okay, so you should just know about these changes in colors, that a potassium dichromate turns from orange to green if it reacts with an alcohol. All right. Similarly, there's another oxidizing agent, KMNO4, potassium magnate, which turns purple to colorless if it reacts with an oxidizing, if it gets oxidized. Okay.
Okay.
Before coming on to the oxidation, let's look at the production of alcohols, how to produce alcohols in the first
Yeah.
place. All right. So the first reaction for production of alcohols is electrophilic addition of alkenes. Um, Electrophilic addition of alkenes, we've already talked about that. We've talked about these reactions before as well.
Yeah.
You see, when an alkene reacts with steam, H2O, it
Yeah.
produces an alcohol, it produces a hydroxyl group because this H2O breaks down into OH and H positive. The OH negative, the hydroxyl group gets attached onto the remaining compound, producing an alcohol. So this ethene turns into an ethanol if it reacts with H2O, and H3PO4 in heat is a reaction condition. This is the important reaction condition that you should know about.
Yeah.
Phosphoric acid and heat. Okay, this was one mechanism to produce alcohols. The second one is oxidation of alkenes. If you oxidize alkenes, you can get alcohols as well. For instance, you see this mild oxidation. So there are two types of oxidations of alkenes, mild and strong. In mild oxidation, if you react an alkene with an oxidizing agent, this bracket and O is a representation of an oxidizing agent. It could be anything over here. It could be KMNO4, could be K2CR2O7. All right. Once you react an alkene with an oxidizing agent, you see these two double bonds, they open up and you get these two
Yes.
hydroxyl groups on both of the sides. So this is the alcohol that you get after oxidation of alkenes. And the third reaction to produce alcohols is nucleophilic substitution of halogenoalkanes. We've also done this reaction before. You see how you had a halogenoalkane over here, bromoethane, bromine
Yeah.
attached onto an alkane chain. You reacted it with NaOH, which is because you're trying to substitute OH in place of Br. This is the reason why we're using NaOH over here, because NaOH would give us Na positive and OH negative ion. And this OH negative ion would replace this bromine negative and get attached onto this carbon chain, producing ethanol. Do you get it?
Okay. Yes.
Yeah, so this is how nucleophilic substitution of halogenoalkanes can also give us alcohols. And then there's reduction of aldehydes and ketones. We're going to come back to it later because we haven't covered aldehydes and ketones. So we'll talk
Yeah.
about it after we cover this topic. This is another reaction that can produce alcohols. Okay. So there are
Okay.
altogether 4 different mechanisms that you can use. In fact, there's another one as well. Carboxylic acids, then esters. You see, we haven't still talked about carboxylic acids, but I'm assuming since you've done your GCSE chemistry as well, so you must
Yeah.
have a general idea of what carboxylic acids are. Yeah.
Yeah.
So if you reduce a carboxylic acid, a carboxylic acid can produce an ethanol upon reduction by removing water from it. All right. Similarly, you see under the action of nitrogen, nickel catalyst and heat, you can also get an alcohol in H2O. Yeah, so these are these two reactions of reduction of carboxylic acids. And then hydrolysis of esters. Esters, I'm also assuming you know about esters because
Yeah.
this was also a part of GCSE chemistry. Esters are products that you get after reaction of carboxylic acids and alcohols. And if you hydrolyze an ester, if you react an ester with water, you're gonna get a carboxylic acid and an alcohol. I mean, it's a reverse reaction. So basically, when you react a carboxylic acid with an alcohol, you get an ester and water. The backward reaction is known as hydrolysis. If you react an ester with water, you're going to get an acid and an alcohol again. For instance,
Yes.
you see this was an ethanoic acid and ethanol. I'm going to look at this reaction in the reverse direction. All right. If you look at it from right hand side to the left hand side, you had an
Yeah.
ethanoic acid, you had an ethanol. Both of these groups, H and OH, reacted to produce this ester group. This is the ester functional group, C double bond O and O. And if you look at this reaction in this direction, you're going to get an ester and H2O. This is the H2O. This H and OH would react together to form water. And if let's say you look at it in the reverse direction now, the backwards reaction, which is known as hydrolysis, you're gonna be given with an ester, ethyl ethanoate in this case, with H2O producing the resulting compound, which was in the first case, the reactants. All right. So
Yeah.
technically what happens here is that this bond gets broken, the ester linkage, and
Yeah.
this H2 also gets broken up. This H2 would give you an H positive ion and OH negative ion. Yeah. So this one of
Yeah.
the H positive ions would get attached onto one of the compounds. For instance, if we let's say notice over here, this first one, this bond would be empty. Yeah. it would basically attract this OH, and the bond with this oxygen over here would just attract the hydrogen, producing OH. So you see, you're getting this alcohol and an ethanol and carboxylic acid, yeah, just because
Yes.
the ions of H2O, they react with the broken ester, and this is how you get an alcohol again. Okay.
Okay. Yes.
Perfect. Now, okay, this is just a summary of all of these reactions. Electrophilic addition of alkenes, oxidation of alkenes, nucleophilic substitution of halogenoalkanes, reduction of aldehydes and ketones, reduction of carboxylic acids, and hydrolysis of esters. So yeah, this is all, I mean, these are all the chemical reactions that you can use to produce alcohols. Now, once you have the alcohols, we'll see what further reactions and mechanisms these alcohols can undergo to produce resulting compound. Number one, oxidation. So oxidation of alcohols, you see only primary and secondary alcohols are oxidized. Tertiary alcohols cannot be oxidized. And if you just look at the general summary, that primary alcohols, they produce aldehydes, and aldehydes can further undergo oxidation to produce carboxylic acids. So this is a chain reaction. A primary alcohol is oxidized to an aldehyde, and an aldehyde is then oxidized to a carboxylic acid. I'm going to explain this right now after just this description, that how do aldehydes react with oxygen and how they produce carboxylic acids. But for now, just know that this is a chain reaction, okay? Similarly, secondary alcohols, they're oxidized to ketones only. There's no further chain reaction after this. Ketones is where the reaction just ends, okay?
Okay.
And tertiary alcohols, they cannot oxidize. Simple. You can use these two oxidizing agents, K2Cr2O7, potassium dichromate, and KMnO4, potassium magnate, all right?
Yeah.
We've already talked about the color changes as well, orange to green in case of K2Cr2O7, and purple to colorless in the case of KMnO4. Now, let's look at the reaction mechanisms. Let's look at how these compounds are basically produced. So let's discuss aldehydes and ketones first of all. If you look at the second compound over here, this is an aldehyde. So if you look at now focus on just the functional group, you see a carbon attached with a double bond oxygen and one hydrogen. So this is the functional group of an aldehyde, where there's an oxygen and a hydrogen. That's it. Okay.
Yeah.
So this was a primary alcohol initially, ethanol, C2H5OH.
Yeah.
It got oxidized into an ethanol is basically the resulting aldehyde. So aldehydes have this suffix called al, all right? You just add al at the end of all of the compounds. For example, if let's say ethanol converts into an aldehyde, the resulting compound would be called ethanol. If let's say methanol gets converted, it will be called methanol, all right? So this is how the names change according to these suffixes. So coming back to this reaction, you see how this primary alcohol, so basically what happened over here was that this OH, this OH was, you see, these hydrogens were broken down. The double bond, a double bond was formed with the oxygen, and you were just left with one other hydrogen. So this is how this is ethanol produces an aldehyde. And then once you further react this aldehyde with an oxidizing agent, you're gonna get a carboxylic acid, because you see you get more oxygen in oxidation, and more oxygen means that this hydrogen would react with more oxygen atoms, producing OH. So OH over here makes up a carboxylic acid. All right. So this is how this reaction proceeds. Any questions so far?
No.
No. Okay. All right. Now the second one is oxidation of a secondary alcohol. Number one, why is it? Sorry, no. Okay. This is an aldehyde turning into a carboxylic acid. Just a general reaction of, let's say, if you were, let's say, just given with an aldehyde, and if you try to
Oh,
oxidize aldehyde, you can still
yeah.
get a carboxylic acid because aldehydes,
Oh,
they do undergo oxidation. This is the major difference between an aldehyde and a ketone. Ketones cannot be oxidized. Aldehydes can go
me.
undergo oxidation. Okay.
Okay.
So yeah, so this is just an experimental setup of how you can obtain an aldehyde. You can just ignore this. For now, let's just talk about how um, again, you see there's ethanol producing aldehyde and H2O. I'm going to skip these experiments because they're not really related to the syllabus. Oh, okay, let's talk about the oxidation of secondary alcohol. Now,
Yeah.
if you notice, and before that, let's just discuss ketones. This compound over here is a ketone. If you notice, the functional group of
Yeah.
ketone is just oxygen double bonded to carbon.
Yeah.
And the identification is that this C double bond O would always be found somewhere in the middle. You can never have the C double bond O at one of the ends, because if you do, that will be an aldehyde. Imagine if there
Yeah.
was a double bond oxygen over here. So this is an aldehyde.
Yeah.
This is another difference between an aldehyde and a ketone, that an aldehyde has the C double bond O at the end, and then there's just one more hydrogen on that side. Whereas a ketone has this C double bond O anywhere in the center, anywhere in the middle of the compound. So this
Okay.
is the identification of a ketone. You see, you had the secondary alcohol in the beginning. It got oxidized. It produced a ketone and H2O. I mean, this is just the reaction over here. What happened here was that this hydrogen was removed, the double bond was broken, this H was also removed. Both of these hydrogens with the oxygen supplied through oxidation produced H2O at the end, and both of these double bonds just remained as they were with the oxygen producing the C double bond O. Okay.
Okay.
So aldehydes and ketones are together known as carbonyl compounds. And both of these compounds, they have this carbon to oxygen double bond. This is the identification. But the difference is that an aldehyde can be oxidized to a carboxylic acid, a ketone cannot be oxidized. So yeah. And they can be prepared through this oxidation of primary and secondary alcohols.
Okay.
Testing for oxidation products to see whether the compounds can further get oxidized or not. You can use these oxidizing agents other than potassium magnate and potassium dichromate. Felling solution is an example. So Felling solution is basically a compound containing copper 2 ions, and it acts as an oxidizing agent. If you react, if you react any compound with a Felling solution, basically these copper 2 ions, they get reduced, and you get a color change of, you could say, blue to red. All right.
Okay.
If you let's say it's big, because copper is blue in nature. Copper solution is always blue in nature with CO2 positive ions. If you,
Yeah.
let's say, get an opaque red color, it'll confirm, I mean, it'll test positive with an oxidizing agent, any compound that gets oxidized. So for instance, if you pick up an aldehyde, and if you
Yeah.
react with an aldehyde with the Felling solution, you'll always get a
Yeah.
red color solution. Whereas
Yeah.
if you pick up a ketone, the solution will just stay blue because the ketones, they're not oxidized. This
Oh,
is one of
okay.
the tests. This is how you can differentiate between aldehydes and ketones. Similarly,
Okay.
you see, okay, yeah, this is just an example. Clear blue solution initially, this is how this solution would remain as it is under the presence of a ketone, and this
Yeah.
is the red solution whenever there is a compound that gets oxidized. There could be an alcohol getting oxidized over here. There
Yeah.
could be carboxylic. There could be an aldehyde. There could be an alkene or anything at all.
Yeah.
Okay, so you can choose
Okay.
Felling solution for any oxidation. Similarly, the second solution is a Tollens reagent. A Tollens reactant is basically a compound that has Ag positive ions, silver ions. And these silver ions would produce a silver mirror or a layer of silver, a dark silver layer. You see, this is how the color
Okay.
would appear. A very light silver mixture would turn into a very, you could say, dark silver color, and it's known as a silver mirror. Okay,
Yeah.
and you're gonna get this whenever a compound gets oxidized under the presence of this reactant. For instance, again, if you react an aldehyde with a Tollens reagent, you're going to see a silver mirror on the sides of the apparatus. If you, let's say, react a ketone, the reactant would just remain as it is because the ketones, they're not oxidized. Okay.
Okay.
And yeah, so we're done with the oxidation of alcohols. Is everything clear up till now?
Yes.
Perfect. What we're going to do now is we'll just move on to this, the questions, some practice questions now. Okay. Just
Okay.
from the oxidation of alcohols. I'll just need a few minutes. I'll share this document with you. Oh yeah. So there are two assignments that we need to get done. The first one is from alcohol production because we've done these two topics from this unit, this module,
Yeah.
production of alcohols and oxidation of alcohols. So the first assignment is from the production and the second one is from oxidation.
Okay.
So